Okay, guys, today we were talking about scientific notation and expanded scientific notation, and we got playing around with it and working a bit. I want to first go back to what we did yesterday and then show you how it leads right into today. So the first way we reviewed from yesterday of representing a number like 34,765 was just in expanded form. Expanded, if you remember, just takes each number as its in its place value and uses distributive property to break them all apart. So this 3 here we know is 30,000. Then we're going to add in 4,765. So that was the first way we were looking at it yesterday. And then we started saying, okay, there's something called expanded notation. And with expanded notation, it takes just expanded form into another level. So it takes this 30,000 and breaks it up into units of base 10 numbers. So in this case, this same number would, 30,000 would be 3 times 10,000, or 3 groups of 10,000 is 30,000. And this would be 4 times 1,000. 4 times, 4 groups of 1,000 is 4,000. And we continued on. It wasn't, I'm not saying it wasn't too hard, but you've seen this before, and it was a quick review for most of you, and people were doing just fine with it once we got started. So that's in times 1, but I don't have room on the board to do it. Anyhow, that's where we were yesterday, and I said, okay, there's going to be something new today, and it's going to be scientific notation. But what kind of led us to that today was when we had this number here with a decimal in it. So let me give myself some room to work. When we had a decimal number, there was now some decisions to be made. So in expanded form, this is just 400 plus 50 plus 6. So that's expanded form. And in expanded notation form, this would be 4 times 100 plus 5 times 10 plus 6 times 1. The question we had is, what do you do with these decimal numbers? How do you represent them in expanded form, and how do you represent them in expanded notation? And we hadn't talked about that yet. Today we came up with some people working. They said, well, we could represent 3/10, this 3 right here, as a fraction. It says 3/10, so we can write it as 3/10, right, as a fraction. And just like this column here with the 4 is in the hundredths column, we can represent that as 4 100ths. When we go to expanded notation, however, we got to take that same idea and we're going to add 3 times something with a base 10 number, and that's the part we didn't know. I'm going to put the answers on here, but I'll back up in just a second to show how we got it, because that's what led us to the conversation today. This 10th is actually times 10 to the negative 1, and this 4 hundredths is represented by 10 to the negative 2. Don't worry if you've forgotten, I'm going to show you how that works out. So when we do scientific notation, we looked at little ideas of what it does. Anyhow, it's used to make numbers smaller and easier to use. And it uses the number 10. Find a different color than black. Uses number 10 and an exponent to represent the place value, what it's representing. When we make these numbers smaller, when we're trying to make these numbers smaller, they're still in thousands and hundreds of thousands. Anyhow, all we're going to do is change the exponent above the 10. We're going to increase that for every place value that we move. And that's as we get bigger, we're going to increase the exponent above the base number. When we hit a decimal, that's when we started to go into negative exponents, and we're going to show you how that worked out. Anyhow, to backtrack, we know that 10 as a multiplication question of base 10 numbers is 10 times 10. And another way of representing 10 times 10 as an exponent is 10 to the power 2. A 1,000 is similar. When you break it down, it's really 10 times 10 times 10. And if we were to work that into a base 10 number with an exponent, it would be 10 to the 3, which is not 10 times 3, that would be 30. But it's 10 times 10 times 10, just like above. And again, 10,000 as an exponent, or sorry, as a multiplication question is 10 times 10 times 10 times 10. And that is simply 10 to the 4. One of my students said today, well, if it's a positive number, it's really easy to figure out what number goes here as the exponent, because you just count the number of zeros in your question. And he was right. 100 is 10 to the 2. 1,000 is 10 to the 3. 10,000 is represented by 10 to the power 4, to the exponent 4. Then we had a question like 10. How do we get 10 as a multiplication question? If we try to do it like above, it's really just 10 times 1. There's only 10 there one time. So if we wanted to represent it as an exponent, an exponential number, it would be 10 to the exponent 1, or 10 one time. And we were even okay with that. And then we hit 1. 1 is that trick question that you get introduced in grade 8, but it's going to be the first question they throw at you in grade 9. And because we're going all the way into our negative numbers, into our decimals, not negative numbers, we're going to go into decimals, which will be represented by negative exponents. We have to know that this is also something. So as crazy as it sounds, 1 can be represented as 10 to the 0. But in fact, we started playing around with it, and any number can be represented. So if you wanted to have, if I asked you what 9 to the 0 is, it is also 1. So then, if you remember, we just did the positive numbers first. I'm sorry, I misspoke. Not the positive numbers. We did the numbers greater than 1 in the ones column. We didn't go in towards the decimals yet. So anyhow, but we talked about it, and your number is 3,250. And every time we went this way, we increased the exponent by 1. But the question that we've pondered today is, what happens if we're going towards the tenths and hundredths and thousands column? What happens as we head to the right of the decimal? And we put it out as a logic question, and we said, well, if this is 10 to the 1 and 10 to the 2 and 10 to the 3, and even 1 is 10 to the 0, and we just started looking at the numbers, we took an educated guess and said, well, maybe you write a decimal in exponential form with a negative on top of it, just like a number line or a thermometer. And it was a wonderful guess. It's exactly what happens. So then we started talking about numbers like decimal 1. And we started as, because that would be our first column to the right of the decimal. And if we were going to write that in exponential notation, it would be 1 times 10 to the negative 1. If we started to get into something larger, like decimal 000, we would have, oh, and I got to put a number down there, 7. We are going to be moving 1, 2, 3, 4 columns, and that's going to be 7 times 10 to the negative 4. Because you're actually showing this column is the one you're working on, and you're going to put that decimal right there. So we started playing around with that today, and then we did a whole bunch of, where am I? We did a whole bunch of practice ones. I just got to move some stuff around. There we go. So we put down in no particular order a bunch of numbers that we could practice with. Now the trick with today's work, where we're just starting to work and express these as exponent with base 10, is to have only one number and a bunch of zeros. So we'll just put a bunch here, and I want to mix in some decimal numbers at the same time. Decimal 0006 and number 4, decimal 004. We practiced these for about 20 minutes today, and people were starting to get them. But 80,000 is 8 times 10,000. And 10,000, if I write it above you just so you can see it, we know that 10,000 written as a base 10 is 10. And then if you remember our trick and just count the zeros, it's 10 to the exponent 4. And we were getting really quite good at that, breaking it apart to be what number times 10 to what exponent. So if we're looking at this one here, 400, it was 4 times 100, so we knew that in our head. And then just by counting the zeros, most people are easily able to say that it's going to be 10 to the exponent 2. Anyhow, these ones were really coming along, but this is 6 times 10, and you have to count not just the zeros, however, it's how many places you're moving the decimal. So in this case, a little bit different than above, it's actually 1, 2, 3, 4. 10 to the negative 4. That was the little bit of difference today. And here in this last one, it's 4 times 10 to the negative 3, because we're actually moving that decimal place 3 places to make that number happen. So anyhow, that's what we're practicing. And just very quickly, I want to show you what we were thinking about for Monday. Monday is going to be the exact same thing, except this time you'll have a number like 24,000. And if I'm going to ask you to express that in scientific notation, you know we have to somehow it times 10 to an exponent. But some kids didn't know, do I write 24 here? They weren't quite sure what we're going to do here. So that's the question I'd like to ask you. What numbers do I put here? And what number do I put here? If we're going to do scientific notation, and your number isn't just one single whole number. That's where we're going. Know it, don't know it, ask, look it up, and we'll discuss that on Monday. Have a great weekend. Don't spend all your money at the fair.